So if you're listening to this right now, take a quick look at your hand. Do you have a gold ring on? Or, well, even if you don't, you're probably holding a smartphone, right?
Yeah, which has, microscopic gold contacts inside it.
Exactly.
Yeah.
And the thing is, when you look at that metal, you're not just looking at some standard rock we dug up. You are looking at literally the direct physical residue of two dead stars
Why?
violently colliding in deep space like billions of years ago.
Yeah.
It's cosmic wreckage. Wreckage that somehow survived the Earth forming, got pushed up through the crust by boiling underground water, and was eventually just, ripped out of the ground through staggering human labor.
It really is wild when you frame it like that. I mean, it's a material that totally forces us to reconcile astrophysics with economics and chemistry with deep human psychology. We use it constantly, but we rarely actually stop to ask, how did it get here?
Right.
And why this one specific element? Why did it organize so much of human history?
Which is exactly why we're doing this. Welcome to the Deep Dive. Today's mission is customized specifically for you, the listener. We are going fundamentally deep into a material that has essentially held humanity in this psychological and economic chokehold for millennia.
Gold.
Yeah, the heavy yellow metal.
Right. We want to answer the core question of why this exact metal became the backbone of empires, and honestly, why it's still so incredibly vital to the future of our technology.
And to do that, we are anchoring this whole deep dive in a really extraordinary set of source materials. We were given this massive, wildly comprehensive document. It's literally just titled gold.pdf.
Yeah, gold.pdf. So mysterious.
Right. But what makes it so unique isn't just the data. It's not a standard geological survey or some dry textbook. The framing is, well, it reads like highly researched, very personal notes addressed to someone named Liz.
Yes, the voice is so distinct. The author uses all these affectionate, intimate markers, calling the reader tiny scholar or sweetie or morsel.
Yeah, it's very conversational. It is. And it even references this personalized Lizianity lexicon to categorize human behaviors.
Mm.
And it's such a brilliant device because it takes this subject that could easily just be a boring list of atomic weights and commodity prices, and it injects it with this interpersonal drama. It makes the geology feel intimate.
Which you really need, because to actually understand gold, you have to start with the geology, or I guess more accurately, the astrophysics, because the story of gold, it doesn't start in the ground at all.
Yeah.
It starts entirely in the sky, long before the Earth even existed.
Right, because so heavy elements like gold, they can't be made in normal stars like our sun, right?
Exactly. Our sun is a massive fusion reactor, sure, but it's mainly just fusing hydrogen into helium.
Yeah.
And eventually it'll fuse lighter stuff up to carbon and oxygen,
Okay.
but it just doesn't have the mass. The gravitational pressure isn't high enough to fuse heavy elements. Once a star tries to fuse iron, the reaction actually consumes energy instead of releasing it.
No.
Yeah, and that triggers the death of the star. So to make something as heavy as atomic number 79, which is gold, you need an environment of absolute cosmic violence.
Just total destruction.
Exactly. The physics require a mechanism called rapid neutron capture, or the R process. And this only happens in the most extreme places in the universe, like a supernova, or more specifically, when two neutron stars collide.
Okay, wait. For those who might not know, a neutron star is basically the ultra-dense core that's left over after a massive star collapses, right?
Yeah. They are so dense that if you took just a single teaspoon of neutron star material, it would weigh billions of tons here on Earth.
A teaspoon. Billions of tons. That breaks my brain.
It's absurd. And when two of these stars get caught in each other's gravity and spiral into each other, the collision generates temperatures and pressures that completely break our standard models of physics.
And that's when the war process happens.
Right. During that collision, atomic nuclei get bombarded by this massive wave of free neutrons. They capture these neutrons so fast that they build up to these immense atomic weights before they even have a chance to undergo radioactive decay.
So it's basically building the heavy atoms instantly.
Literally, in a fraction of a second, this
Yeah.
violent celestial forge creates heavy elements like gold, platinum, uranium, and the explosive force just blasts them outward into interstellar space.
So it's just drifting out there.
Yeah, for eons. And eventually, some of that stellar dust collapsed into the nebula that formed our solar system, and ultimately the Earth, roughly 4.5 billion years ago.
So literally every atom of gold on this planet is ancient.
Oh.
Like the notes say, it's glamorous cosmic wreckage.
Glamorous cosmic wreckage. I love that line. But there's a massive geological problem here. When the Earth was first forming, it was just this molten, chaotic ocean of magma.
Oh, it's all liquid.
Yeah. And during this period, you get planetary differentiation. The heavier elements sank toward the center of gravity, and the lighter silicates floated to the top to form the crust.
Oh, and gold is insanely dense.
Very dense. 19.3 grams per cubic centimeter. Almost twice as dense as lead. So naturally, it sank. But worse than that, gold is what geologists call a cytophile element.
Meaning it's iron-loving?
Exactly. It bonds and mixes with iron really easily. So when all the Earth's iron sank down to form the planetary core, almost all the primordial gold just followed it right down to the center of the Earth.
So technically, the crust of the Earth should be completely empty of gold.
Completely depleted. It should be locked away thousands of miles beneath our feet. Totally impossible for any human to ever reach. The fact that we can actually find it on the surface requires a whole secondary delivery system.
Enter the asteroid bombardment.
Right. The late veneer hypothesis. Long after the crust cooled and turned solid, the inner solar system was basically a shooting gallery. The Earth got pelted by meteorites and asteroids.
And these asteroids were made from that same original stellar cloud.
Exactly. So they had their own heavy metals. And because the Earth's crust was already solid by then, the gold from these impacts just kind of stayed in the upper layers.
Wow. But it wasn't just like evenly spread out like butter on toast.
No, it was super scattered. It took hundreds of millions of years of tectonic activity and hydrothermal systems to actually concentrate it.
Right, the underground water.
Yeah, deep underground, magma heats up water to these extreme temperatures. And under massive pressure, this superheated water acts like a super solvent. It actually dissolves trace amounts of gold right out of the surrounding rock.
And then pushes it up.
Right. It forces that pressurized fluid upward through cracks in the crust, and as it gets higher, the temperature and pressure finally drop. The water can't hold the dissolved minerals anymore, so the gold just sort of precipitates out.
It crystallizes.
Yeah, often right alongside quartz. That's how you get those rich gold veins that miners eventually dig for. It's this insane multi-stage journey. Neutron stars crash, then asteroids hit a cooling planet, then supercritical underground water pushes it up over deep time.
It's like the universe went out of its way to put it right in our path.
Yeah.
And, when early humans finally found it, the physical properties of this stuff were just, well, it's almost unfairly perfect.
It really is.
I like to compare it to, the annoying high school valedictorian who is also somehow the captain of the football team. It's just too good at everything.
That's a great analogy.
Right, because we talked about how dense it is, but it's also incredibly soft. It's just a 2.5 to 3 on the Mohs hardness scale.
You can practically scratch it with your fingernail.
Yeah, it's so malleable. You can take a single ounce of gold and beat it into a translucent sheet that covers like 300 square feet. Or stretch it into a microscopic wire that goes on for dozens of miles without snapping. But, okay, the thing that really sets it apart, the reason anyone even picked it up, is the color.
Oh, the color is fascinating because it's actually a physical manifestation of Einstein's theory of relativity.
Wait, really? Relativity?
Yeah, playing out at the atomic level. Most metals, like silver or aluminum, they reflect all wavelengths of visible light pretty evenly, which is why they look silver or gray to us.
Okay.
But gold is different. Because its nucleus is so massive, 79 protons, the electrons orbiting closest to that nucleus have to move incredibly fast, like a significant fraction of the speed of light, just so they don't get pulled in.
Wow, okay.
And according to relativity, when something moves that close to the speed of light, its mass effectively increases. This makes those inner electron orbits contract closer to the nucleus, which causes a cascading effect, shifting the energy levels of all the outer electrons.
Oh, I see where this is going.
Yeah. So when visible light hits a gold atom, the exact amount of energy needed to excite an electron matches the energy of blue light. So the gold absorbs the blue wavelengths.
And since white light minus blue light leaves yellow and red.
Exactly. The light that bounces back into our eyes gives gold that warm, distinct, glowing hue. The source notes just call it quantum physics showing off.
That is so perfect. Quantum physics showing off. But, okay, let's unpack this a bit. Because early humans didn't have microscopes or chemistry degrees. They didn't know about relativity. How did they figure out it was special?
Well, what's fascinating here is that they didn't need to be chemists because gold is a native metal.
Right. Let's explain that because this is huge.
It's the whole reason humans could use it thousands of years before the Industrial Revolution. Think about iron. Iron reacts fiercely with oxygen. It rusts. If an ancient person tripped over some iron in the woods, they wouldn't see shiny metal. See a brownish-red, ugly lump of ore.
And to get the metal out, you'd have to invent a smelting furnace that can reach massive temperatures just to break the chemical bond.
Exactly. Copper turns green, silver tarnishes. But gold is chemically inert. It resists oxidation, corrosion, almost all acids. It's a noble metal.
So it just sat there.
Right. An ancient human is walking by a riverbed. Millions of years of erosion have washed this gold out of a quartz vein, and because it's so dense, it just sank to the bottom of the stream. And because it doesn't react with water or air, it just sat there, bright yellow, in its pure metallic form.
No smelting required.
None at all. They just reached into the cold water and pulled out this mathematically perfect element. It survived planetary formation, erosion, deep time, and just looked totally immune to decay.
And that leads into what the author calls the magic ratio, because
Okay.
gold basically won the metal lottery. It's rare enough to trigger our psychological sense of scarcity, which makes it valuable, but it's common enough and spread out enough across different continents that totally separate civilizations could find it and use it.
The magic ratio. If it was as rare as, say, francium, it would just be a scientific curiosity. You couldn't build an economy on it. And if it was as common as iron, it would just be building material. No prestige at all.
It's the perfect middle ground. But that accessibility is kind of a trap. I mean, sure, the early stuff was just lying in the rivers, but the overwhelming majority of gold on Earth, getting it out, is a distinctly imperfect earthly nightmare.
Yeah. The source document calls gold a conversion machine. And this is where the physical reality of the metal just violently clashes with the whole idea of purity.
I love that mechanical metaphor, the conversion machine. You convert a mountain into ore. You convert the ore into this toxic slurry. The slurry becomes a doré bar, which is like a semi-pure block of gold and silver. Then you ship that off to be converted into pure bullion.
And the bullion converts into wealth, the wealth converts into power, and the massive chemical waste left behind converts into, well, someone else's permanent problem.
It's such a brutal paradox. We use gold for wedding rings to symbolize pure, untarnished love, right?
Yeah.
But the origins of that ring are mud, sweat, toxic mercury, debt bondage, sometimes child labor.
The history of extracting it is basically just a history of scaling up environmental devastation. Once the easy surface gold was gone from the rivers, ancient miners realized they had to actually break the quartz rock itself.
Which meant fire setting.
Yeah, they go deep into these primitive, unventilated tunnels and build massive, intense fires right up against the rock face, get the quartz superheated, and then just throw freezing water on it.
And the thermal shock just shatters the rock.
Violently. It fractures it so they could pry out the gold. It was incredibly dangerous, suffocating work. But then, the Roman Empire showed up.
Oh, the Romans. They always have to take it to the next level.
They realized that human muscle and fire just weren't efficient enough. They wanted to move entire landscapes, so they engineered this technique called ruina montium, literally translated as the ruin of mountains.
Las Medullas in Spain, right?
That's the most famous one. They built vast networks of aqueducts to cache water at high elevations, piped it into reservoirs above these gold-bearing hills. And meanwhile, they carved out a super specific network of tight tunnels inside the hill.
And then they just drop the water.
They opened the floodgates. The hydraulic pressure of all that water rushing into the tight tunnels compressed the air inside until the sheer physical force literally blew the hillside apart.
They blew up mountains using fluid dynamics.
2,000 years ago, and if you go to Las Medullas today, it's a UNESCO World Heritage Site, but it looks like the surface of Mars. The land was so traumatized by this extraction that the scars are permanent.
It's just left there.
Yeah.
And modern industrial mining, it's just that, but amplified by scale and chemistry. We have open pit mines that are literally craters miles wide. You can see them from low Earth orbit. And then there are the deep underground mines, like the Witwatersrand Basin in South Africa.
Oh, the deep mines are terrifying. Some of them plunge over 4 kilometers deep into the Earth's crust.
4 kilometers.
Yeah, and at that depth, you are actively fighting the geothermal gradient. The ambient temperature of the rock down there can be over 140 degrees Fahrenheit.
You just cook.
They have to use massive industrial refrigeration systems just to keep the miners from dying of heat stroke. And the physical pressure of 4 kilometers of rock above you, the tectonic stress is so high that the mines suffer from what they call rock bursts.
Where the rock just explodes.
The walls literally explode inward into the tunnels because the pressure is just too immense.
Unbelievable.
Mm.
And once they haul all that deep rock to the surface, the chemistry starts. because they aren't finding nuggets anymore. They are chasing microscopic flecks of gold locked inside tons of rock. You can't pan for that. You have to dissolve it.
Right. And this is where cyanidation revolutionized the industry in the late 19th century. Gold is basically chemically inert, but there is one major exception. If you have oxygen and water present, cyanide will react with gold and turn it into a highly soluble gold cyanide complex.
So modern mining uses heap leaching. They take millions of tons of low-grade crushed rock, pile it on this massive lined pad, and literally just drip sodium cyanide solution over the mountain of dirt for months.
It percolates down, dissolves the microscopic gold, and they collect the pregnant solution at the bottom. Or, if it's higher grade ore, they do carbon and pulp. They mix the crushed rock into a liquid slurry in these huge vats with cyanide and activated carbon. The carbon absorbs the dissolved gold.
And it works. It's incredibly efficient. The EPA says cyanidation recovers like 85 to 98% of the gold, but the risk, it's catastrophic. Cyanide is incredibly lethal. If the liner's under a heap leach pad tear or a tailings dam breaks, which by the way has happened multiple times in places like Brazil and Romania,
It wipes out entire river ecosystems instantly. Heavy metal toxicity just washes downstream.
the longer-term threat is acid mine drainage. Right?
Yeah, acid mine drainage is insidious because when you rip deep underground rock to the surface, you are exposing sulfide minerals like pyrite to oxygen and water for the very first time in millions of years.
They react.
The iron sulfide, water, and oxygen react to produce sulfuric acid. And then this highly acidic water acts like a solvent, leaching heavy metals out of the rock. Lead, arsenic, cadmium. It creates this toxic, rust-colored runoff that just bleeds into the groundwater.
And the worst part is, it doesn't even need active mining to keep happening. The chemical reaction is self-sustaining. A mining company can close up shop, go bankrupt, leave town, and that site will just keep hemorrhaging sulfuric acid into the water table for centuries.
It's a permanent wound, but, while the industrial side relies on massive capital and deadly chemistry, the informal sector is, well, it's arguably an even darker reflection of human desperation. The source document puts heavy focus on artisanal and small-scale gold mining.
ASGM. And we have to be clear about the scale here. When we say artisanal, we're not talking about a couple of hobbyists with pans in a local creek.
No, not at all. The UN Environment Program estimates that the artisanal sector produces roughly 12 to 15% of the global gold supply, and the EPA says it could be up to 20%.
20% of the world's gold. Dug out by hand. There are an estimated 10 to 15 million artisanal miners operating around the world right now, mostly in South America, Sub-Saharan Africa, and Southeast Asia.
And the demographics are deeply, deeply troubling. The International Labor Organization has heavily documented this. There are an estimated 4 to 5 million women and children in that workforce.
Kids digging unstable, unreinforced shafts by hand. And they're often locked in severe debt bondage to local cartel bosses or informal financiers. But the truly defining characteristic of this artisanal mining is how they get the gold out of the dirt.
Because they don't have multi-million-dollar cyanide vats.
Right. So they use mercury amalgamation, which is a rudimentary, devastatingly toxic process. They crush the rock into a fine powder, and then they mix liquid elemental mercury directly into the dirt, often just mixing it with their bare hands.
Mercury is unique because it easily forms alloys, called amalgams, with other metals like gold. So the liquid mercury binds to the microscopic gold flakes in the mud, and it creates this heavy, silver-colored lump of mercury-gold alloy,
which they can just sift out of the mud. But to actually get the pure gold to sell, they have to separate the alloy. So they put the lump in a pan, and they apply direct heat, usually just using a blowtorch, in their backyard or sometimes literally in their kitchen.
Which is horrifying because the boiling point of mercury is much lower than gold. So the heat vaporizes the mercury into a highly toxic gas, leaving behind a little porous bead of relatively pure sponge gold.
And the health impacts are just incalculable. The miners, their kids, they are directly inhaling concentrated mercury vapor. And mercury is a potent neurotoxin. It severely damages the central nervous system. Tremors, cognitive degradation, kidney failure.
And the vapor that drifts away just settles into the local waterways, where aquatic microorganisms metabolize it into methylmercury, which is an even more dangerous organic compound.
And it bioaccumulates.
Exactly. Small bugs absorb it, small fish eat the bugs, big fish eat the small fish. The concentration magnifies all the way up the food chain, eventually poisoning the exact same communities that rely on that river for food.
The EPA actually states that artisanal gold mining is the single largest source of human-caused atmospheric mercury emissions globally, almost 38%, just from people with blowtorches trying to survive.
Which brings into focus what we can call the hierarchy of profit. This is a structural reality of the gold industry that has barely changed since antiquity. The physical, chemical, and toxic risk always travels downward. But the economic profit, that always travels upward.
Yes. The people physically breaking the rock and inhaling the vapor, whether they were enslaved by the Romans or indigenous populations forced into the Spanish encomienda system or modern artisanal miners in the Amazon, they absorb 100% of the biological danger. But the wealth flows seamlessly up.
To the colonial empire, the central bank, the luxury jewelry house.
The tech manufacturer. The World Gold Council launched these responsible gold mining principles back in 2019, but, can a certification actually fix a problem that is this deeply structurally embedded?
It's really hard to say. In lots of artisanal setups today, the miners are forced to sell their crude gold directly to the local buyers who sold them their tools, right? And they often only get maybe 70% of the global spot price. They take a massive financial loss on their own perilous labor just to subsidize the top of the supply chain.
So despite all of this staggering human and environmental cost, humanity has literally never stopped digging for it. Why? Because the physical permanence of gold, the fact that it refuses to rust or decay, made it the absolute perfect psychological vehicle for early empires to project eternal power. Whoever holds the gold writes the history of the world.
It's the bright, heavy spine of human civilization. We can literally trace how its function evolved over time. In antiquity, the value was theological. To the ancient Egyptians, gold was equated with the actual physical flesh of the gods.
Right, like King Tut's mask.
Exactly. When you look at the burial mask of Tutankhamun, you aren't just looking at sovereign wealth, you are looking at theological matter. They buried pharaohs in tons of gold because the metal's incorruptibility was required to ensure the soul's immortality in the afterlife.
It was literally a magical material to them. But then the Roman Empire comes along and transitions it from theology into the ultimate tool of statecraft, the aureus coin. It let Rome project its imperial reach, pay massive standing armies across Europe, and enforce taxation.
And in medieval Europe, they used it to adorn cathedrals, gold leaf everywhere, using that luminosity to turn spiritual authority into overwhelming visible splendor.
And we can't forget West Africa. The geopolitical gravity of gold was huge there, long before European colonialism. The great West African empires, Ghana, Mali, Songhai, they built immense power by controlling the trans-Saharan gold trade.
They moved massive amounts of gold out of the interior, trading it for salt and tying their economies directly to the Mediterranean and the Islamic world.
The best example is Mansa Musa, the ruler of the Mali Empire in the 14th century. When he made his pilgrimage to Mecca, his caravan carried so much gold, and he gave so much of it away in Cairo and Medina, that he massively devalued the local currency. He literally caused hyperinflation in the Middle East purely through the volume of his charitable giving.
That is raw macroeconomic power. But that same metal, that same hunger for bullion, drove the catastrophic European conquest of the Americas. The search for El Dorado wasn't just a fun myth, it was a policy directive. And it resulted in systemic enslavement and genocide of indigenous populations to fill Spanish and Portuguese treasuries.
And then by the 19th century, that imperial hunger sort of democratized into something much more chaotic. The gold rushes.
California in 1848.
Australia, the 1850s, the Witwatersrand Basin in 1886. These weren't just localized mining booms, they were demographic detonations.
They really were. Finding alluvial gold triggered massive, frantic global migration. It created instant, sprawling cities out of complete wilderness. San Francisco and Johannesburg materialized almost overnight. It spurred transcontinental railways, deep water ports.
It aggressively accelerated globalization, but again brought immense violence, displacement of native peoples, and set up deeply racialized labor hierarchies that lasted a century. It turned geography into pure speculation.
And through all this, gold solidified its role not just as a commodity, but as the ultimate form of money. And if you want to understand why gold won the currency war against every other material, you have to look at Jevons' paradox of money functions.
Right, a currency has to be durable, divisible, portable, recognizable, and scarce.
And gold is perfect for all of them. Durable, doesn't rot like wheat. Divisible, melt it and split it, it's still gold. Portable, a single coin holds massive purchasing power in a tiny volume. And universally recognizable. A gold coin is an argument you don't have to explain. The weight proves its value physically.
But the truly wild thing about the economics of gold today is its position as what we can call the anti-promise. Let's really dig into this because it perfectly highlights the difference between commodity money and modern finance.
Yes. In modern finance, basically every asset you own is a derivative of language and trust.
Right. You buy a tech stock. That is a legal promise of future earnings. You buy a treasury bond. That's a promise of repayment with a yield. Even fiat currency, like the US dollar, is just a promise.
A fiat currency has zero intrinsic value. It's only backed by the full faith, credit, and taxing authority of the government. Its value exists entirely because of social consensus and legal enforcement.
But gold promises absolutely nothing.
Nothing at all.
It has no yield, no quarterly dividend. It doesn't hire workers or invent tech or produce cash flow. An ounce of gold sitting in a vault today will be exactly 1 ounce of gold in 100 years. It just sits there, silent and heavy.
And that refusal to participate in the productivity of the economy is exactly why people want it. It functions as an economic anchor. When the promises of the world start to fracture, when investors fear runaway inflation or banks collapse or wars threaten fiat stability capital, immediately flees toward the asset that has zero counterparty risk. Gold is trust stored outside of language.
So what does this all mean? It basically means gold acts like a mood ring for global civilization.
Oh, a mood ring. That's good.
Right. When trust is high, we wear it as jewelry. When trust falls apart, we hoard it in vaults as an apocalypse shelter. You don't have to trust the government if you hold a gold bar. You just trust physics.
And you see this in the markets today. Look at the COMEX, the primary derivatives exchange for precious metals. When geopolitical fear spikes or central banks aggressively expand the money supply, institutional investors flood into gold futures.
In May 2026, COMEX futures spiked above $4,700 an ounce because of central bank buying and fear. The price of gold is literally a direct measurement of global anxiety.
If we connect this to the bigger picture, though, relying on gold as the backbone of a modern economy actually creates severe structural problems. We saw this with the gold standard trap.
Right, where paper currency is directly tied to a fixed amount of physical gold. It was the foundation of global finance for a long time.
And it created phenomenal international stability. It forced governments to be disciplined. You couldn't just print money to fund a war. You had to actually acquire the gold. But that rigidity became absolutely catastrophic during the Great Depression.
Because during a deflationary spiral, when banks fail and unemployment skyrockets, a central bank needs to expand the money supply to stimulate the economy. Lower interest rates, inject liquidity.
But under the gold standard, they couldn't. If panicked investors started exchanging paper money for physical gold, the central bank actually had to raise interest rates to protect its gold reserves, which actively strangled the economy even more.
It was a lethal straitjacket. Gold is amazing at preserving the absolute value of a currency, but terrible at preserving people during a crisis. It lengthened the Depression until we finally had to abandon the metal to save the economy.
But even after we completely untethered our money from it, the psychological obsession didn't break. We can't just view gold through macroeconomics. We have to look at the psychological and symbolic spell it casts. The notes provided to us frame gold as an emotional technology.
Emotional technology. Evolutionarily, human brains are hardwired to notice bright, reflective surfaces, right? Because a shimmer usually meant fresh water in a landscape. So we are biologically predisposed to stare at it. Gold triggers those latent instincts.
But it goes beyond biology. It solves a really complex visual problem for human religion. Across cultures, the core challenge of theology is representation. How do you physically show a divine entity that is supposed to be invisible?
You need a material that looks otherworldly. Gold answers that problem by glowing. Because of relativity, it looks like frozen sunlight. Earth rendered celestial.
So we use it to adorn temples, paint halos, plate the roofs of shrines. Not because the gods need money, but because human worshippers need radiance, a tangible surface to project transcendence onto.
But religion also warns us about the danger of it. The mythologies are full of warnings. King Midas given the power to turn everything to gold, only to realize you can't eat metal. He starves amidst infinite wealth.
And the golden calf in the Abrahamic tradition, Moses is getting the law, and the Israelites melt their jewelry into an idol. It's the ultimate warning about humans mistaking the symbol of the sacred for the sacred itself. It starts as an offering, but its material presence is so intoxicating that it just replaces the divine. Pure idolatry.
And this duality bleeds into how we use it for status and luxury. Gold is the ultimate performer of contradiction. It's sacred, but also vulgar, masculine and feminine, ancient and futuristic.
Which is where the Lysianity lexicon in the source text comes in. It explicitly groups gold, jewels, and diamonds with 4 powerful concepts: luxury, excess, distraction, illusion. Gold is a visual command. It says, look here. And like moths, we usually do, it dazzles the eye but fundamentally misdirects the
It
mind.
has total queen bee energy.
Queen bee energy, exactly.
Like coal or iron feel industrial,
Yeah.
martial. Gold doesn't whisper utility. It announces sovereignty. But the source asks this incredible question. Do we love what is beautiful, or do we love what others agree is valuable? Like to the listener, when you want a heavy gold watch, are you captivated by atomic number 79 or by the invisible social consensus?
We're captivated by the scarcity. But scarcity is often a social construct. We restrict access, build faults, hallmark the purity. Gold activates our evolutionary fear of running out of resources, of falling down the hierarchy.
But it solves that abstract fear with a heavy, tangible possession. You don't have to believe in it like a banking app. It physically validates itself.
Philosophically, it symbolizes permanence in a world obsessed with decay. We die, kingdoms collapse, but gold just waits. We use it to symbolize what we fear losing most: power, beauty, love, identity.
So given all this ancient superstition, you'd think in our modern era of AI, cloud computing, space exploration, that our obsession with the shiny rock would fade. But here's where it gets really interesting. The future of technology is actually more dependent on gold than the ancient world was.
We've split gold into two economies: the symbolic economy, jewelry in India, China, the Middle East, central bank reserves.
And the technological economy, which is invisible but completely critical. Because gold is highly conductive, malleable, and completely resistant to corrosion, it's irreplaceable in electronics, in servers, smartphones, aerospace visors.
If a copper contact in a server farm oxidizes, you get a cascading data failure. Gold guarantees reliable conductivity. And in medicine, we use gold nanoparticles. They don't trigger immune responses, and they have surface plasmon resonance.
Meaning their electrons oscillate with specific light wavelengths, allowing highly sensitive diagnostics and targeted drug delivery.
And in aerospace, NASA uses it for thermal control. The James Webb Space Telescope mirrors are coated in pure gold because it reflects infrared radiation flawlessly.
It's incredible irony. The exact same metal ancient pharaohs worshipped to attain immortality is now coating space telescopes so we can look back at the origins of galaxies. But this tech reliance creates a paradox on Earth: urban mining.
Right. Because we put gold in billions of short-lived devices, a single ton of discarded smartphones can contain up to 300 grams of recoverable gold. A traditional mine moves a ton of rock for just 5 grams. Our e-waste stumps are richer than natural ore bodies.
And we're also trying to digitize it. Bitcoin is heavily imitating the psychological narrative of gold: scarcity, decentralization, distrust of fiat.
Bitcoin is digital alchemy. It proves that even when we invent frictionless virtual wealth, we still rely on the conceptual template of gold to understand what value means.
But this raises an important question. What happens if space mining succeeds? NASA is sending a probe to Psyche, an asteroid potentially filled with gold. If we bring massive extraterrestrial supplies to Earth, and gold is no longer scarce, does the magic ratio break?
The industrial price would crash, but would the symbolic prestige survive? We might just artificially restrict it. Demand certification that it's Earth origin gold. This is the central contradiction of modern gold, the digital paradox. The more virtual and algorithmic our wealth becomes in the cloud, the more psychologically we crave the heavy, undeniable reality of a gold bar. You can hack an exchange, but you can't delete an atom of gold.
Let's pull all of this together. We've gone from the collision of neutron stars to the circuits in your smartphone. What is gold, really?
It's geology turned into hierarchy. It's sunlight made tradable, beauty with a body count. Above all, it's humanity's ultimate mirror. It didn't make us greedy or artistic. It just gave us a durable canvas to express what we already were.
So look at the gold around you today. On your wrist, in your tech, you are looking at cosmic wreckage that outlived empires, shaped by human labor and desire. But I want to leave you with one final, provocative thought. We obsess over gold to achieve permanence and escape decay. But if medical science or digital consciousness ever truly cures human aging, if we finally achieve the immortality we've sought for millennia, will gold lose its value overnight? Or would we simply find a new reason to hoard the one metal that survived the journey with us?